Okay, I think we're going to get started with the afternoon sessions. Okay, so I think just to give a bit of background as to how we've structured the afternoon session, the first session will be dedicated more to women who are in their mid or senior level of professions in terms of having a data science career, whereas the second session would be dedicated more to young professionals who are in the process of entering a data science career or have just entered their professions. So that's the difference between the two sessions that we will be seeing this afternoon. And through both these sessions, we will be obviously focusing on women that are within the data science profession at various levels, and they're going to be telling us a bit more of how they got into the data science field and what was their career journeys. So that's the focus of the two sessions that will be led this afternoon. And with that said, I would like to introduce the first speaker, which is Caroline Zabarowski from South Africa. So Caroline completed her PhD in astrophysics at Oxford University, after which she undertook a postdoctoral fellowship at Princeton and the University of KwaZulu-Natal in South Africa. She has worked in various technical roles in the gaming and finance industry and has experience as well in leading the development and implementation of data science strategies with large corporations. Caroline is currently the Chief Data Officer of an AI startup in California. And with that, I'm going to leave it to Caroline to tell us a bit about, some more about her and what her career journey is. Thank you, Caroline.
Thanks, Bonita, and thank you everyone for letting me tell you a bit about my background in terms of data science and technology in general. I'm just going to share my screen. Right, I'm a bit less familiar with Zoom, so let me see if I can go into full screen mode. Can everyone see my screen?
Yes.
Okay, great. Yes, thank you for the opportunity today. When I looked at the request for what I should talk about, I wasn't sure what to name this talk. So I guess just in keeping with what Bonita just summarized for us, today I'm going to be telling you a bit about my story in the context of my career in data science. So I thought, this is one woman's journey in the field of data science. And I thought I would also, given that I'm of the more senior group, I would just maybe focus on 5 tips or pieces of advice that I would give to younger people in this field, and what certainly would have helped me to know when I was more junior. So as Bonita said, she summarized my history in terms of technology quite succinctly. My bachelor's degree was in physics and chemistry, and then I went on to do an honors in physics, and then I chose astrophysics for my PhD and my MSc at UCT. So it was actually very nice to see some old faces like Carolina and Bonita, who were colleagues when I was in the field of astrophysics. I continued in academia with a fellowship at Princeton and then at UKZN. And then I eventually joined the physics faculty at UKZN, and I was there for about 4 years. I currently live in Durban, South Africa, but my role, as Bonita says, is actually based with a startup in California, which means my working hours are terrible, given that they are 10 hours behind us, but I've learned to adjust. And my role is Chief Data Officer of our company. To give you just a brief overview of what our company does, we have an internal AI platform, which we use to build predictive solutions for external partners and clients. We operationalize the solutions, and these solutions deliver predictive analytics, which then are incorporated into their decision-making process in order to make decision-making data-driven. I'm part of a small executive suite, and I'm the technical lead of the executive suite. So I do all the guidance in terms of the evolution of our platform, the functionality of our platform, and then of course the management of the technology team who is building the platform. So I have quite a different path in terms of my career, but certainly one thing which has always governed my decisions when making choices about changing my career is that I've always tried to stay true to my ultimate goal, which is to continue growing as a technologist. And I feel like that has stood me in very good stead. It means I've always been interested by the jobs that I do because I'm never bored. And it has meant that I've been able to advance at different stages into more to roles higher up. So just to give you just a breakdown of my career path in terms of the details. So as I said, I was a faculty member at UKZN before focusing on astrophysics. So you can imagine all of the extremely useful transferable skills I gained by being in the field of astrophysics for about 12 years. You know, there's all sorts of data processing understanding that is required, especially given that I was working in the field of observational cosmology. So this means that you're not only building very complex models, but you've got a horribly complex data set to deal with. So it certainly has been, it was a great starting foundation in terms of my career into data science eventually. My second role, which I took after I left the faculty of UKZN, was actually as a mathematician for a gaming company. It was my first big foray into more frequent statistics away from Bayesian statistics. It's the first time that I had to start trying to understand what executives care about as opposed to what data scientists find interesting, and making sure that we were building and reporting things that would be useful to the executive team, who would then go out and make implementation changes in order to improve the business model. It was also, it saw me adding a lot of computer languages to my toolkit, such as C#, Excel, and was my first big launch into SQL, which has been very useful up until now. I was a mathematician for about 1.5 years, and then I decided to move into a more management role as the chief technology officer of a fintech startup. So this was an asset management company, and we built a platform which allowed us to automate the investment process. Through the automation of the investment process, it meant that we could reduce the fees on asset management, which is is extremely important, given that fees can be extremely expensive. This was the first time that I applied data and machine learning models to things like anti-money laundering, as well as fraud. And what we also did is we made the process called Know Your Client, or the essentially the verification process of onboarding someone who wants to invest. We made that data-driven as well. So what that meant is that we could streamline many of the processes and actually take those processes away from humans, allowing the humans to actually focus on the more important tasks that require humans. This was interesting because it also allowed me to, for the first time, develop a large team of developers, which can be a lot like herding cats in terms of trying to keep them focused on the objectives. And then again, I honed my skills on communicating to a non-technical audience. So having to report to our board on progress. Again, some really useful insights into how to assess, again, what is important to people higher up the food chain. And then a large part of what I learned was in database design, which is, again, stood me in quite good stead going into my new role. Sorry. And then the first time that I actually moved directly into the field of data science was in 2017. This is where I decided to consult on my own. This was an extremely challenging time and extremely interesting. At that time, being a consultant, I was the person who was held responsible for anything that's for any outcomes. It was incredibly liberating because I could choose what I wanted to work on. But of course, what came with that was quite a lot of responsibility. But I really enjoyed that. And that's when I really started to get into the thick of it in terms of machine and deep learning algorithms and the application to delivering value to an external company. The work that I worked on when I was consulting was extremely varied. One of the most interesting and quite out the box projects I worked on was actually a marketing campaign where I had to create a mathematical model which would help Ross from Friends determine the exact angle in which to pivot the couch from the iconic scene in Friends in order to get the couch around a set of stairs given a certain set of dimensions. And I used a simulation to do that, and that received a lot of press. And it was a really fun and interesting project, but quite out of the realm of data science. But during this time, I really started to dive deeply into things like the applications of statistical tests, data mining, and including building apps, which a company could then leverage for utilizing the outcomes, the predictive outcomes that were delivered. Again, I feathered my nest with many skills such as Python programming, and then things like Snowflake, which is a data warehouse. And it was then in 2020 that I was recruited to be the Vice President of Data Science for the company at which I currently work. As I mentioned, they've got an AI platform, and I'm, as the VP of Data Science, I was in charge of building all of the solutions with a team of data scientists for external clients, identifying use cases and then scoping the solutions. And then this leads me to my current role within the same company, which is Chief Data Officer. And as I said, I've now become the technical lead in terms of the executive suite. So I help guide decision-making in terms of what is possible given the technology that we have. So one thing I wanted to point out about my career is that actually, believe it or not, I've never done a formal course in data science or statistics, and I've actually never had any formal training in programming. Now, this is not to say that I wouldn't have benefited hugely from either of these, but my point is that I wanted to stress that these things are not necessarily a prerequisite for moving into the field of data science and being successful in the field. Provided that you have a strong technical background in a variety of STEM subjects, those are more than sufficient to allow you to learn on the job and be successful in the field of data science. And then I thought it would be amiss if I didn't represent or at least show you the role that both life and luck has played in my decisions and my career path. We're not machines, we're humans, and we have personal lives, and it's certainly my personal life has made a big impact on the decisions that I've made. As you'll see, shown by the big events in my life was the arrival of my 3 children, as well as meeting my husband and getting married. And as you'll see, they actually very closely coincide with the big changes in my career that I've made. And I just wanted to drive home that it's okay to have a personal life, and your personal life will absolutely impact the choices that you made. For example, when I decided to consult on my own, as much as I had loved my role as a chief technology officer, I needed more flexibility because I had 3 children under the age of 2. And it was wonderful that I had a husband who could support me. And so that was obviously that had a big impact on the decision for me to go and consult, to become a consultant at that point. And not everyone necessarily is going to choose these make these conventional decisions that I've made, but more to the point that that life happens, and you will have seasons in your life, seasons where you will be able to work very hard, seasons where your career needs to take a back seat. But the point is that it's still possible to make gains. And luckily, the world in which we live, people are very accommodating of the fact that that people may have big events happen in their life, like the arrival of children. And then in terms of luck, certainly luck has played an important role in my career. When the lockdown happened in 2020, this is when the marketing director of my current company actually reached out to me to do some science writing, which is something that I absolutely love to do. Upon meeting him, he introduced me to the COO, and the COO actually said, would you rather just like to come and work for us? And of course, had lockdown not happened, and had we not all had a work from home mandate, our company almost certainly wouldn't have been as open to have having someone from South Africa work for them. And so certainly luck has played an important role in what has happened in terms of my career path to date. And then I thought I would just kind of summarize with 5 take-homes from my own experience. So firstly, as I said, I don't think that necessarily having a specific degree in data science is absolutely necessary to do well in the field. Of course, it will stand you in very good stead. But I think as long as you have a solid training in science or a related field, and you are honest and you stick to the rigorous application of the scientific method, I think that is more than enough to stand you in great stead. When carrying out data science, you are being given an enormous responsibility. And I think it's very important that you carry out data science as responsibly as possible. Everyone's very familiar with typical biases that can creep into data sets. For example, sample bias. This is where you've collected a data set in a way that it does not necessarily represent the reality of a production environment. This can be extremely dangerous because it means that your models or your solution can perform far better than what will actually happen in production. Or you get things like confirmation bias. And this is where you are less critical of data or outcomes which confirm your predisposed expectations. In astrophysics, this was certainly something we had to be aware of when we were trying to look for deviations from the concordance model of the universe. And we had to make sure that we weren't biased towards those models which actually confirmed our expectation of dark energy being Einstein's cosmological constant. And then, of course, there is AI bias. And AI bias feeds into a big focal point in AI at the moment, which is AI fairness. So AI bias is where an algorithm actually produces results which are systematically prejudiced. And the reason for that is that there is some sort of erroneous assumption that is made in the machine learning process, or it can happen due to biases which are incorporated into the data collection stage. So at our company, we're highly aware of these biases that exist in historical data, and we try and correct for those biases which have been incorporated due to historical inequities. And this is extremely important also in regulated fields in which we work, such as financial services and healthcare. So just to be aware that this is now an emerging field, and these historical biases need to be accounted for. And then the last point on responsible data science is just a focus on transparency. There is a large focus on explainability when it comes to building AI solutions or conducting data science activities in order to help with the adoption of AI and machine learning driven insights into corporations or companies. There's often resistance if the people who are going to be utilizing the insights do not have an idea of how the predictive insights were generated. So it's very important that you are transparent about the way in which you've collected data and the way and why the model is behaving in which the way in which it does. And it's very important to communicate that back to the people who will be eventually utilizing that intelligence. And so that's a big focus point in the industry at the moment, and it certainly will lead to far more responsible data science. Another take home that I would like to drive home is something that I definitely employ myself is continuous learning. I read and question. Our team has an internal R&D platform in which we discuss articles that we're reading. And I would say that if you feel like you're at the top of data science and understand everything that there is to know, I suspect you're not reading enough. It's an incredibly dynamic field which is constantly evolving. Whenever my team is struggling to build something and it's incredibly difficult, and the papers that we're reading are from 2021, I remind the team that the harder this is, the higher the barrier to entry, and of course it means that we're doing something new and novel. And I encourage you to not only read, but also question what you read. The number of articles that I've read which have just been completely wrong. The last paper we reviewed in our brown bag lunch was actually written by a Google someone who worked at Google and who had a PhD, and it was entirely wrong. So be extremely critical with what you read, and just because it's been published, it does not necessarily mean that it's 100% accurate. But definitely, if you continue, if you have a full commitment to continuous learning, you'll do very well in this field. And then as you rise up the food chain, as you start to take on more managerial roles, I would also suggest something I've tried to implement myself is always to remain technical. It's extremely difficult to give valuable advice to someone who is in the technical details if you cannot read code and if you cannot build something yourself. So keep up your coding skills as you rise in the managerial chain. At the moment, my job is extremely varied. For one day, I'll be speaking to investors who want to understand how we plan to make money. The next day I'll be sitting with the developers and looking through the code, trying to figure out what is the best methodology to implement. And I think if you remain technical, it makes your job much easier, and it also keeps a happier team. And the last thing I wanted to focus on is something more personal. This is the elusive balance to which everyone refers. Even at the age of almost 40, I can't say that I've actually achieved the perfect balance between my home life and work. I'm a perfectionist, but I have to try, and it is a daily struggle for me to make sure that I'm happy with the amount of work that I'm doing and the amount that I'm doing as a dedicated parent. I've certainly found some variant of that elusive balance, and I still seek out advice from more senior people that I meet, especially women, to understand how they strike that perfect balance between the mother that you'd like to be and the worker that you would like to be. The one thing I have managed to do in my old age is definitely understand and identify which are the highest priority things that need to be done to my absolute best ability, and to identify those which can, be a B+ in terms of effort. And I think if you can start that process of understanding how to identify those situations now as younger technologists, I think that'll stand you in very good stead later, where you have, larger commitments outside of the work environment. And that's all I had to say. So thank you very much. And I believe we will be taking questions after the session.
Thank you, Caroline. I think you've answered one question that was posted on work-life balance by Noftolo. Yes. Okay. I think you've just answered that one question. But yes, if there are any questions for Caroline, please post it to the Q&A. Caroline, I know you have to just quickly run out.
But I will be back.
But yeah, you'll be back for the Q&A. Thanks very much for that.
Very much. Sure, thank you.
All right. I think we're going to move on to our next speaker, which is Celia Cintas. Celia is currently based with the research scientists at the IBM Research Africa, based in Nairobi, Kenya. She's part of the AI science team at the Kenya lab. And I know she's focusing also on a number of different applications, machine learning applications. And one of those are to address challenges on the global health in developing countries. And I'm hoping she's going to talk a bit about that. And Celia holds a PhD in computer science from, I'm probably not going to pronounce it properly, Celia, Universidad del Sur in Argentina. And I know that she's originally from Argentina. Welcome, Celia.
Thank you very much, Bonita, for the introduction. Let me share. Can you see my full screen?
Yes, I can see your screen.
Perfect. So let me start with a little bit of background. As Bonita already mentioned, I'm from Latin America, for the southern tip in Patagonia. I did my PhD in computer science, but I had the luck of doing it in the Patagonia Research Center, and we had a very interdisciplinary team. And actually, we were part of Latin American diversity studies. So we get to interact with anthropologists, sociologists, biostatisticians, geneticists, and people from computer science, of course. All my undergrad and graduate studies were not being possible if they were not available scholarships and fellowships that I learned applying on the road. For my PhD and postdoc, we have the Science and Research Council in Argentina that we can apply for fellowships, and through other mechanisms like Marie Curie funding and other Hispanic Latin American countries association with Spanish countries, we were able to get internships in other laboratories, understand how other universities are run, how different these research topics are covered, and so on. Also, during my PhD, I had the privilege to be able to, again, through travel funding, attend to international conferences in different parts of the world, and again, gain some knowledge of what was being researched at that time in very diverse applied machine learning topics across the globe, and bring that back home and see how we can adjust or fit it into our context. During my PhD, also applied through a lot of different awards of projects that we were building, mainly machine learning and computer science applications for social impact. Also, during even my undergrad till the PhD, I was a teacher assistant, a student assistant, and all the process levels till a professorship where I did my undergrads. That gave me the chance to interact with younger students and discuss which topics were of interest of them and so on. But something that was very clear to me is that everyone gets here with a different set of privilege, a different set of access to information or encouragement or funding. And I think one of the ways that we can help is building community around, connecting mentors with mentees, connecting funding with amazing candidates for different research purposes and so on. And also getting topics like getting data science, robotics information to younger kids so they can know that what is available in terms of the future that they want to study. We also organized this first SciPy conference in Latin America that is actually still running. I think this year is going to be Brazil. But this was a way to connect people with programming skills and domain experts from everything, from genetics to astrophysics to geology and so on in the Latin American context. So how somebody from Patagonia landed in Nairobi. So thanks to Grace Hopper Conference, if you don't know it, is a conference for computer science and women in STEM in general. I was a scholar for a few years and I got to interact with the amazing Aisha Walcott, that she's a researcher here at the Nairobi lab. We got to chat of different research topics that could align and could be applied here in East Africa, problems that the lab was trying to solve. So this was my transition from still research, but from academia to industry. I joined for 2 years as a postdoc fellow here at the lab. Currently, I'm a research scientist at the AI science team. So particularly today, I want to show off some work that we are doing in the AI science team. We also have collaborations with other universities, and also we usually talk a lot across different IBM research labs across the globe. But today I'm going to talk about these particular collaborations. Our teams are usually built with engineers, research scientists with totally different backgrounds, master's and PhD students, interns. So if you think that any of these topics will be interesting to you, please ping me and we can talk later on. So the AI science team is led by Skylar Speakman, and something that we're actually interested is build robust models. Don't worry, this is not a deep learning talk, but basically we want to study out of distribution samples. These type of samples that can be or common data shifts on our information when we took it to production. Some type of data vary over time or vary over geography, or actually is samples that are perturbed. If these type of samples get into our system and we generate a misclassification or a wrong prediction, it could have a serious risk with real world consequences, such models that are already in healthcare, predicting health outcomes, robotics, or financial services, and so on. So basically, what we are interested is how can we help models that are being already trained by brilliant data scientists, and we want to help to evaluate or aid which type of data these models are being ingesting and predicting outcomes on it. Of course, as you can imagine, you can think of 1,000 of different out of distribution issues. Today, I'm going to talk about 3, but how the same method apply to everyone. So first are the serial attacks that basically is adding noise that the human cannot detect, but can actually change the outcome of the prediction of a model. What happened when my model is trained on a set of conditions, skin conditions, and a new one appear? How can I be robust to new samples? And also analyzing with the big boom of gangs is how to detect that the image that we're taking on is real or was synthetically generated by the model. So again, on this type of methodology, we are not building new architectures, new models. We are rather using them as data generating systems, and we can apply pattern detection and statistical models to actually see how the model behaves internally. And after we have some quantification of the model, we can actually search very efficiently which are the group of activations that are looking anomalous or not behaving as expected. Some very nice properties that this type of approach has is we can provide the detection improvements at runtime. We don't need to retrain the model or have labeled examples of what the anomaly or how the adversarial attack looks like. And we can abstract from domains and only focus on one type of representation. This means we can work with temporal sensor data, we can have text data, we can have images, and so on. So what we are assuming is that when an out of distribution or a new class image or sample pass through the network, we have a different set of activations values. But how do we measure that difference or that anomalousness? We use some non-parametric scan statistics features, where it gives us a way to measure how much these distributions deviate from what we expect. So something that is important is how do we put these type of measurements into a pipeline? So any data science that has already their model built, what they actually do is extract the inner representation of that model. Cannot be only deep neural networks, but a lot of other ways. We build a representation that tells us what is expected of the model to behave, and we can search and rank which values are actually anomalous. So this is very nice because you have two things. You have a score that is telling you to flag an element to say this element looks weird, and I'm not used to processing this type of information. And you also will have information of which nodes contribute to that anomalousness. So you will have information of what causes the anomaly alarm. So as I mentioned, we have different results that I'm not going to argue on. But for example, we have adversarial attacks, this way to perturb samples, and how can we detect this when there is a change. We have this great work done in audio, a command that you're giving to your home device and to say something different. That work was led by Victor Akinwande, one of our previous engineers, as the same that we do with images. Another very interesting topic was detection of changes in the skin condition classifiers. So I have a model that is diagnosing a certain of conditions. How can we prevent two things? First, what happened when a new condition arrives and my model didn't know it? And second, what happens is the environment change. The lighting of different practitioners' room will vary, or the type of the hardware that is taking the picture also changes. Not only we study the anomaly detection there, but we also study how these models perform in dermatology, in particularly for different type of skin tones. This work was led by Tim and Newton during their master's student internship a few years ago. I will left at the end some papers if you're interested. But the idea here is that with one statistical method, data science-oriented method, we can help complex deep learning models to get better detection accuracy and be more robust against shift on the data. All the code for this is available for this and other applications is available on the Linux Foundation AI repository, and they're open source, and of course you can play around with them. Some other research at the lab that is super interesting and has similar technology behind is finding subgroups in with people on different outcomes. So you can actually find out in healthcare domain what group with certain attributes is being misclassified at a higher rate. We also have our work on fairness of classifiers across the skin tones that is super interesting, and other applications domains such as audio and so on. So my 2 cents will be in middle-ish career advice. Is context matter, access to information, to what is possible, on how to write a funding grant application matters. So building community helps you lower the barrier for other people that may have not access. Inclusion also matters. And when I say inclusion, it's not diversity of having one of each, but actually that the people feel safe and raise concerns in the research group, in the lab, or the institution that they are working on. Be kind to the others, that pays a long way. People will be more comfortable with you of sharing new ideas, on discussing topics, and building long research relationships for sure. Apply to everything. I think this was said before on the sessions in the morning, but don't use that internal filter that I'm not good enough for giving this talk, for applying to this scholarship, for this job position, and so on. You will gain a lot of knowledge in the process of applying. Always reach out to mentors that already take that path, and you want to say, how can I apply to this type of position? From my PhD, I learned that technical solutions must be built into interdisciplinary, especially in data science that we rely so much of data. We need to understand how the data was collected, what was the social context, where some questions were like this or like that. It's very important. And something that I think is you don't need a data science degree to access. And I think as more diverse you get, you have more point of views, more set of values that are analyzing one technical solution. So that's key and super important. On the machine learning, taking to production your work, I will say we need to be explicit in which context they work, in which geography, which population, be very explicit at the limitations, and be transparent. If you search for certain biases What type of metrics do you use? What types the mitigation techniques that you use? Being explicit is the best policy to people to trust on your models and solutions. Thank you very much. Hope I'm not too much over my time. And thank you.
Thank you, Celia. Thank you so much for sharing some of the work that you're doing at IBM Research Africa, Kenya. If there are any questions for Celia, just post them in the Q&A and then we'll address them after the final talk. Okay, I think we're going to move on to our